we start our presentation, which we entitled Long Short Global Macro Strategy with Target Beta using the three-factor models. Before starting, let's briefly introduction to ourselves. My name is Yuki, and I'm a financial engineering student, and will be graduating into the May 21. And the co-author is Theo, is also from the financial engineering. And here's the agenda. We start with the historical background of theory with French Fama three factors model, and then explain the investment universe strategy and introduce the performance and risk metrics and result and discussion.
Next. Okay, sounds good. All right.
Oh, here's Fama French three factors model. So historically, so early to middle 20th century, the researcher developed the CAPM, which the return has a positive relationship, a linear relationship. But after that, the middle to later 20th century, some researchers found anomalies that cannot explain by the CAPM. The representative is a size effect, leverage, look to market ratio, and earning per share, earning per profit. So the French and Fama developed their model empirically to aggregate the four anomalies factor into size effect and the book to market ratio. And the mathematical form of the model is given in the lower of this slide. Next, please.
Okay.
So here's the investment universe we analyzed. That we choose 12 EDS from which represent the global economy, and we set investment horizon as March 2020, 2007 to October 30th, 2020. So we spread the time horizon into 5 sub-periods: the pre-subprime, during subprime, post-subprime, and pre-COVID and during COVID. We didn't analyze the post-COVID because we don't have enough data set. So investment strategy is we analyze the following 6 look-back periods and 6 target betas. The upper index indicates that the look-back periods to estimate the returns, and the lower index shows the look-back periods to estimate the covariance metrics. And we choose a target beta, which is -1 to 2. And our optimization function for this portfolio is shown below. Yeah. So we introduced performance and risk metrics, and we discussing it later in the results and discussion section. So I think it's no need to explain them all, and we focuses on the cumulative return and Sharpe ratio, as well as the risk volatility, and also the annual bar, which is represent how the trade-off of the performance and risk.
Thanks, Yuki. Can everybody hear me as well?
Yeah, we can hear you. I can hear you.
Okay, great. So I will proceed with the quant analysis and what we did for the coding and the results, and maybe have a short discussion about them. So we try to identify different combinations of look-back periods for both the covariance and the expected returns, and we just combined those. We had different combinations of those with the 6 betas that we chose. And here we see the value of the investment strategy during the original period, which is pre-subprime crisis, or pre the credit crisis. But we also wanted to go further and just look at the PDFs, just look at the distributions, maybe get a clearer picture of what beta is more appropriate for each of the different estimation terms that we chose. As we'll discuss at the end of the presentation, the winner here, the top performer in this situation, in this specific investment horizon is the one with beta of 2 and 120 for both the covariance and the expected returns re-estimation terms. And here we can see the different distributions of the returns for all of the combinations of for all of the different combinations of look-back periods and the estimation terms. Similarly, for the period during the credit crisis, we have a similar result. We have a top performer here, which is again the longest look-back period for both the covariance and the expected returns with a beta of 0.5. And again, we can see the different PDFs for this specific arrangement during this section of the investment horizon. And this is the graph for the post-credit crisis. The top performer, the short factors and beta of 2. The PDFs of the different combinations. And lastly,
did you go bankrupt or not? Because I see that you
in this graph.
Yeah.
Yeah. So we have some issue with the data here because we decided to include the one that you told us not to use, the one that closed. I think it's the ETF from Africa. And that only had data until like mid-2017. So that's what we suspect happened there. But yeah, we're still not sure how to interpret that.
Yeah, because what this means is that once you cross 0, that means that you are bankrupt, you're out of business, basically. Right.
Yeah. So we just think that this is a glitch. Looking at the PDFs as well, which are just like distributed in similar ways as the previous ones for the different estimation, for the different covariance and expected return estimation terms.
Yeah, because I think that what happened is that if you do that, at some point, your covariance matrix will, well, if you put the graph and at some point it's not here anymore, the covariance matrix will go just singular. And in each case, your optimizer will not return a solution, and you keep the last weights. You're gonna keep the same weights all the time.
Understood.
Yeah, so and that's what's hurting you, because you start not making money, and you'll be losing continuously money.
I see, because
so that's why you you went underwater, basically.
That makes sense. Yeah, it's that currently the way the model is standing, it's that it keeps re-estimating different weights. So would your suggestion be to keep the weights at that last point where data is running out, or where the covariance matrix goes singular, and then continue with those?
Because when it goes singular, what you need to do is you need to remove that line, that column.
I see.
Continue with the remaining ones.
That makes sense.
Because when it's singular, the quality optimizer cannot give you a solution. So as you input, now I think that it's going to return the first thing it will get during iterations.
Right.
And I suggest that either it returns something which is just a feasible point, or maybe it will just take the WP, which was one of the inputs of the optimizer.
I see. Yeah. That's great. Yeah, we'll make sure to include that in the paper as well.
Yeah, and
then
that's likely what happened.
Yeah, and then lastly, for the pre-COVID-19 period, we have the different distributions here for the different betas. And here, similarly, we see the period that we're in right now, which is like the start of COVID all the way to the present, up until October 30th, 2020, to be exact. And the top performer here is a short-term 60-60 for covariance and expected returns with a beta of -1. And here we can see similarly the different distributions for the different betas. So for the discussion, as I've described, like the top performers from the different candidates, we chose based on a variety of factors. So for the pre-housing crisis, it was the low drawdown and the large Sharpe ratio as a combination that made us choose this specific portfolio. And then the highest return on low volatility with a low volatility portfolio during the subprime crisis, the 120 with a beta of -2. And for the post-housing crisis, the short-term portfolio, the short factor portfolio with a beta of 2 had the largest Sharpe ratio and the highest cumulative return from its counterparties. And then in the period before COVID, the highest return, lowest volatility portfolio was the 6120 with that specific beta of 1.5. And for the on COVID-19 period, the 9120 was the best performer. And we thought that the target beta was to be expected because a decorrelated portfolio performs better than the market when it's under stress. And the relatively shorter term ones are, or the short factors also contribute to that. So in terms of the general theory, our conclusions were that the portfolio sensitivity to beta terms, or regarding that, there wasn't a clear relationship, but what we did observe was that the expected returns had a significant relationship to the estimation terms. And the term structure also played a very important role, but still less so than the estimation terms alone. And lastly, the first day of each look-back period strangely affected the strategy returns. And we observed that in all of the different iterations of this experiment.
Yeah, to that point, actually, what happens for the first day of each look-back period is that the penalty term is written as the difference between the new weights you are trying to generate and the previous one. So which means that if you don't want to be too dependent to the first allocation, you need to take a smaller lambda. So that's the key to, it's the answer to what you observe. Because the bigger lambda is, the more you're going to stick to the first allocation. By reducing the lambda, you'll be allowing your portfolio to have more turnover. And the key is, well, can one find kind of optimal balance between allowing, between less turnover and a little more turnover to get some performance.
I see.
So that's the thing. And now the second thing is about the risk attitude. When you take beta equals 1 or anything greater, so basically you are trying to replicate the market risk. And question is, how can you replicate the market risk while generating some alpha? Right? And what you are saying is that, and that others said also is that if you want to do that, then you need to learn more from history, right? And try to increase the window, but it's also taking some risk. And you should see it in terms of what is the variance risk or the CVAR. That should be, I think, pretty high in your case. But, I don't have the numbers because it was like a few slides ago, but you are generating these results with windows of 120, 120, but at the potential price of high VAR and high CVAR. I think I see 200% somewhere. So that's kind of balance. When you may think about that when you are trying to find investors for this portfolio.
Absolutely. Yeah, and that's something we did observe that this kind of model with a beta strategy alone, utilizing the multiple regression, might not be enough by itself for a sound investment, in the sense that if we paired it with say a model that is just combined with this, that searches for max return or searches for like a target return, and could potentially incorporate like the C bar that you said, or just observing it might just give us like a more nuanced result in a sense.
Yeah, in the sense that you may want to say, okay, if you want to do that, don't try to overshoot on beta, because you may say pay it as a higher C bar. But good analysis.
Thank you.
Thank you.